All right, good evening. My project topic choice was the collapse at the Charles de Gaulle Airport. This collapse happened in May of 2004, just barely making it to a year after its completion, 11 months to be exact. Terminal 2E at the airport collapsed. There were 3 fatalities and 7 injured persons in total. Luckily, it happened at a time where airport traffic wasn't high. It wasn't rush hour. So the first sign that the terminal was approaching devastation was a small chunk of the concrete's outer shell dropped from the bottom, so outside, so nobody inside knew about it. And then an hour and a half or so later, the north wall began to buckle and some of the struts began to further pierce the concrete shell, and then ultimately the entire terminal decided to collapse. The initial accident report stated that there were multiple factors that contributed to the failure of this terminal. As you can see from this slide, some reasons for the failure included inaccurate stress calculations, a lack of proper shear stiffness, a high bending moment, poor reinforcement, a weakened concrete shell, and a rapid temperature change that occurred the night before. As we know from different assignments and our textbook in class, we know how important stress calculations are. That's why we do the actual stress on the structure and the design stress for the structure, so things like this could be avoided. If you see in the diagram to the right, it shows you where the glass outer shell was, the metal struts, and also the concrete shell. That's what the yellow part is. That's the concrete shell. So it shows you how it was set up. It was a basic setup, but as you can also see, in the picture, it shows an oval-shaped terminal. It's because France is known for its futuristic type architecture, but that's besides the point. But as you can see, that oval shape is bound to have many points where its structure could be compromised. So as far as the lack of reinforcements and shear stiffness, it was noted in multiple reports that some of the metal struts actually pierced the concrete and they went in too far. And also, as I said, the rapid temperature change that occurred was a dramatic drop of 30 or 40 degrees. And as most of us know, as metal heats up, it stretches, and once it cools, it begins to contract. So that dramatic change in temperature never allowed it to actually, gradually cool down throughout the night as it had heated up and stretched earlier that day. So after the collapse site was actually studied for a year to actually figure out what really happened, what exactly, caused it. Because as I stated before, there were multiple factors that contributed to it. But one thing was certain all across the board, that the collapse was not blamed on the architect's design itself. It was more so the construction of it. So they eventually rebuilt it and opened it back up in 2008. But rather than going with a concrete shell with metal struts, they decided to go completely with a complete metal structure. And what we got from that collapse, what we learned from it, was that we need more oversight over an entire project. So everybody is working off of the same thing. It goes hand in hand. We need to work together. Not saying that they weren't working together before, but we've learned that we actually need everyone on the same page, the architects, the building contractors, and that there needs to be an additional safety check afterwards, because as you can see from this collapse, safety would have been a better gesture than the aesthetics and the overall eye appeal of the terminal's design. But now it's opened up.